Good morning. Really happy to be here. I don't know how deep this is going to go. Don't get too excited, but also it's funny. Like I haven't, at conferences like this, you don't sleep 9 hours a night, so I'm a little loopy on less sleep. And what that usually means for me is, I'll just be square. I could say anything right now. I don't know what I'm going to say, so we'll see how this goes. So yeah, I'm William, Director of Technical Evangelism. It's a funny title sometimes because my grandma still thinks I work on computers for like a mega church. Like that's her, like seriously. So we might need to work on that. But yeah, I work with Itential. If you want to learn more about Itential, you can go to the expo hall, and if you can follow those neon signs and you'll find us. They stand out very nicely. So. Today, I want to look at something that is a little bit polarizing. And what I really wanted to do with this, and also to kind of preface this a little bit, I was kind of a late addition for this talk in particular. So late, in fact, that I actually started my slides, believe it or not, on the airplane here. And then I worked on them in one of my least favorite places to work on slides now, which was on my bum in the Atlanta airport, which is not fun, and then finished them last night. So, but the good thing is, I have a lot of time invested in this. Well, not for that long, actually, because it's not been around for a year. I think the year anniversary is next week or something, since MCP got dropped. But anyway, let's get started. So I want to look at, is MCP an API abstraction, or is it something a little bit more? Are we even asking the right questions about that? And why is it so polarizing? What are the hot takes? So let's get going. So the obligatory agenda, framing the landscape, framing some of the polarization, but then looking at kind of why was this thing created? Why does it exist? Like, what problem was it actually trying to solve? And for me, not to be self-deprecating, but in the beginning, even though I saw all this hype, 100 new LinkedIn posts a day, I was a little pessimistic. For me, one thing I'll probably do through these slides a lot, and one thing I've done throughout my life is I always throw my hands up, oh, another thing. Do we really need another thing? We have RESTful APIs. We can use RESTful APIs for everything. Come on. And I went through the hard exercise of actually building these out with RESTful APIs and trying to make it work that way to prove that maybe we don't need a new thing. And what I realized was, okay, this actually has a place, and I'll go into why. So I don't think if we compare these things, or we say one is an abstraction over the other, or one is a wrapper over the other, those two things actually get conflated a lot anyway. And those are two different things. They're related, but they're also different. Like a wrapper makes it easier for me to use endpoints, and it just makes things a little easier. An abstraction might make it to where I don't even need to worry about the endpoints themselves. So, words matter, and conflating these I don't think helps much. So we'll look at the RESTful API mechanics, and then we'll go in and kind of layer them onto MCP and look at really what's different, and how it's different. And then a lot of this, I got to say, for a long time, it's science experiment. We're running all this stuff from our laptops. Imagine a world where everybody's running MCP servers everywhere in every way, and that doesn't scale. Come on. So after adding this intelligence and layering that on, what is the play, or what is the path that this is a thing that we can scale, for a large company? So first of all, let's examine the landscape a little bit. So I actually heard this quote right here. I was at a talk, and I can't remember how many months ago, but this is a pretty common one. MCP servers are just wrappers around APIs. Everyone's got a gimmick. And I'm like, oh, come on. No, not MCP. You can't talk about it that way. But then, as I started to think about this, and here I am, already. So I'm going to stillman that argument a little bit, real quick. So if you actually go out and look at a lot of these implementations, that's literally exactly what they are. So you could say that there's empirical proof out there that that's like a true statement, but that doesn't mean that's how it's supposed to be. And I'll get into like maybe why that is and why there's so many of these everywhere here later in the deck. And the second one, and I think this is just, there's no empirical evidence that this is ever going to happen, but there's actually some talk tracks and lines of thought that like, hey, MCPs here, they're going to supplant RESTful APIs, you know, that their RESTful APIs are going to be no more, and that's, I think we can all agree that that's just not going to happen. And then the last one, and this one was interesting. So I remember I got in I wouldn't say it was a debate, but just it was a really good conversation with a group of folks probably earlier this year about this very thing. And what they said was MCP offers nothing beyond this existing function calling mechanisms. And I think to add context for me in this scenario, like what it took for me was actually going and trying to build this and prove that MCP wasn't needed, and trying the function calling methodology, and then trying the, let's import a whole API schema. How does that work, and kind of working through these things. So we will get into that here in a second. But looking a little bit further, yeah, November 25th, that's what it was. I was trying to remember. So yeah, we're almost at a year. I mean, it would have been really sweet if it could have been on this day that I was talking about this. Oh, it would have been great. Too bad. So what is MCP? And I'm just going to read. I took this definition just straight from their GitHub. It's an open protocol that enables seamless integration between LLM applications and external data sources and tools. Okay, that sounds not crazy special. It's okay. But the first thing that, if you're a network engineer, you think of, okay, why do I need this, and like, why should I care? Let's be real. So again, I don't know if I took this from the GitHub or one of their blogs, but basically their definition: without a standard, connecting AI applications to data sources requires custom integrations to every combination. So lots of integrations. We've been down that road before. So I spent a lot of time in enterprise, and just remembering, like, sometimes you talk to a big vendor, you want an integration, and maybe it even somehow gets on the roadmap, and maybe it never happens. Or maybe you work with a medium-sized company, and maybe it takes like 5 to 8 months. Or maybe you bring in a startup that's desperate for customers, and they're like, yeah, we'll have that tomorrow or next week. All of those are valid things that tend to happen. So integrations, it's part of all of our lives. So for me, in the beginning, my pessimistic attitude, it was kind of like not enough. Like, okay, so is this really problematic enough? Again, hands in the air, why do we need another thing? There's so many things already, like it's overwhelming. So what then is the real problem? And the way that I see it, and I think the way that the folks that actually built MCP, there's some blogs, there's a lot of writing out there, but just looking at the N times M, this integration problem, and we'll get into that here in a second. So I love this quote. I've used it a few times. But if our brains were simple enough for us to understand them, we'd be so simple that we couldn't. The Collapse of Chaos, Ian Stewart, great one to have on the shelf. So the N times M problem. And basically what this says basically is N is going to be representative of the number of models. So Claude, actually these are, now that I'm thinking about this, these are not actually models. They're like the AI platforms, but you get the idea, the models under the platforms. So, and then you have all these unique integrations so this maps to the number of tools. So like Salesforce, GitHub, your private things that you've built. So if you think about it, just simple example. So if you have 4 models with access to 10 tools, you have 40 separate integrations, or so the talking track goes. That's a lot of integrations, but at this point, like even MCP on my laptop right now, I'm running probably 4 models with way more integrations than that. So you can see how this would become problematic if you're a big company, and big companies do lots of things, and if this AI thing is going to be as big as everybody thinks it is, there's going to be a lot of this happening. So like we just determined, if you don't have a standard, you have customizations. If you have customizations, you have brittleness. If you have brittleness, hey, things break. They cause outages. Cloudflare could go down. So plowing right ahead. So this, 4 models. Just thinking about this, or trying to think about it, you have this, if you think about developer bottlenecks, and I hate using, like, vendor lock-in talking points are like some of my least favorite things, but I think it's actually interesting in this context, because actually the first thing that comes to my mind when I think of vendor lock-in is Active Directory. Active Directory, the master class there. But then you have, like, in reality, a lot of times with big companies, you'll have things happen like, okay, we're in a single cloud provider, or like we're in AWS. Okay, that's a single point of failure. We don't want to be locked in. Like, we need negotiating leverage, like all sorts of talking points there. So then the logical thing to do is to go into 4 cloud providers, and that will fix those problems. So vendor lock-in in the context of this conversation is a little nuanced. It's actually different because, and I've thought about this a lot, and I would actually love if any of you all after this talk have opinions or thoughts about this too. I just think it's interesting. But it's kind of split. Like, usually it's the vendor. Like, you're the customer, you need more vendors or more things, so you're not locked into a certain type of technology. But this is, if you think about it from the vendor perspective, it's more of like a cost lock-in in a sense, because you have the developers that are building the integrations. You have competitive pressures from your competitors out there. You have pressures from your customers to support more. And hey, back to the last talk, good engineers are in high demand, and they're probably very expensive as well. So that sort of in my mind feeds down to it has a direct impact and a correlation on the customer side, because customers, it's the same thing. Like, it basically they don't have leverage on the vendors and the tool providers and the LLM providers. Like, they lose that leverage, and just more of the traditional sort of view of the vendor lock-in stuff. So it's kind of like a split there. And there's also the high maintenance. I don't want to belabor this point, but very high maintenance, lots of stuff, lots of brittleness. And I think the last one that's important and it's worth thinking about is this quadratic complexity, which is to say not linear. So now if we think of, that's a terrible definition of that. Hold on. That's cheap. If I was in your seat, I would be like, what did you just say? So quadratic complexity stems from something with like models, machine learning called self-attention. And self-attention has, n squared complexity, meaning that, the computational cost is going to scale with the square of the input length. Well, now that I say that, that sounds confusing too. Hold on. So basically what that means is, like, if you have 10 tokens, that's like 100 operations. Or if you have 100 tokens, that is, 10,000 operations. You get the point. It's full mesh. Let's think about it that way. So plowing ahead, the n times m problem. So what does MCP try to do to this to make it better? So of course it's a standard, but you basically, to basically connect that n model to m number of tools, it shifts it to n clients plus n number of servers, so it becomes additive. Okay, so that's easier on the surface. So again, it's so funny because just thinking about my experience with APIs personally, like over the years, I I remember when I first started working with APIs, I was like building like horrible stuff in Perl at the time and horrible stuff in Python earlier on. And there's actually someone here, I don't know if he's in here, but in a galaxy far, far away, when I was in ops, I remember the first time I started building with SOAP, and I was in XML purgatory, and I had like Python, big suds, and I thought I was a real hot shot. I don't know if you're in here, Kevin, but there he is. Funny how small of a world this is, but those were good times. And then REST came along, and I was like, not another thing. That's always my initial reaction, hands in the air, like knee jerk, and then I'll use the new thing, and I'm like, oh, this is good. This was a good thing, so very quick. But I love this quote. In one of my knee-jerk reaction attitudes, someone sent this to me. If we open a quarrel between past and present, we shall find that we have lost the future. I love that. It made it to my sticky note board that I write cool things on when I need a little bit of inspiration. So just, again, API mechanics. So this should be a visual that all of us have probably seen 1,000 times. But I just want to point out a few distinct things before we get to the MCP AI things. So all the way on the left you have the client, all the way on the right you have a server. Okay, it's a client-server architecture. Awesome. It's also more or less a framework. An MCP is a protocol. But I mean, this framework, this RESTful framework, does use a protocol. It uses HTTP. But you have, the way that you're going to structure and start building things, you have these fixed verbs. You have get, you have, put, post, delete. Like, these are the things we do all the time, every day. And so the main thing here to keep in mind is this is like, request, response, request, response. That's the model. There's no state. Like, it's not like you open a session and there's all this state there and you're just continuously doing things back and forth. Client server, request response, stateless. And we should know that, I love firewalls and load balancers to death. They're great but they're stateful. Well, with stateful things break and it's like, so you love them until they break. And that's what we get when we incorporate a ton of state in one place. So when, traditionally, like how we would go about doing this, and one thing, so I in my haste to get these slides done, I failed to make a slide to explain this, but I'm going to have some coding examples I'm going to go through. Of course, you can't fit many lines of code to where anybody can see anything on a PowerPoint slide. So at the end of this talk, there is going to be a QR code. You can scan the QR code. And that is going to take you to the new trendy thing, the link tree, where you have all these links to how to find people. And you're going to find my TikTok, where you can find my excellent dancing videos. And then you will find my GitHub, which will have a project called Talks that's pinned. And within that project called Talks, there will be a folder called 2025 NAF AutoCon or something along those lines. So these coding examples will be in there if you actually want to go in and look at them and figure things out. And another thing too, these coding examples were at a time in my life where I was almost trying to disprove that MCP was necessary. And I'm also a hockey fan. I love hockey. I play hockey. My son plays travel hockey. We're a hockey family. So I find that when I'm trying to learn about something, I kind of use something that is exciting to me. It gets me a little excited. So NHL has an API that you can just use. So I said, hey, that's what I want. I'm going to use that. So that is why there's hockey in these examples. Just throwing that out there. So as we know, we can do an HTTP GET request. We set some headers and some timeouts. We have some URL paths, and we either this is requests in Python, but you open up Postman or however you wanted to do this, great. And then we get, it returns data to us. Well, then with that data that it returns, I need to take out the things in that data and filter the things that are important to me so I can format them, and I just don't want everything. I want the things that I want, right? So I do these things, I run this thing, and then I have this magnificent piece of stats that, I am not an Oilers fan, by the way. I can't stand them, but I am a Connor McDavid fan. I don't know if anybody here follows hockey. It's like watching Magic on ice. He's incredible. Best hockey player that's ever lived. Fastest. His toe drags are amazing, etc. So moving ahead. This is what we've been doing forever. This is, history. So in my mind, early on, I thought, okay, how do I do this and connect LLM and, how do I do this through REST? If we don't want to use MCP, like what are even the options? So the first option that I ran into earlier on is something that I actually don't even know. This is probably the name, or I don't know if it has an official name, but just manual function calling. So in this sort of scenario, you're handcrafting these JSON schemas by hand. It's pretty manual, and there's tons of glue code. There's just lots of stuff that you have to account for. And I think the hardest thing to wrap my head around was actually doing this agent loop thing, which is not. I'm not like a very seasoned like software architect. I'm sure for like the smart software architects, it's like, yeah, I'll just wipe that out real quick. But you have to account for like all the tool calling, the messaging, the tool execution, the state stuff, like all these things. Really it's the orchestration of the conversation flow with the agent. I don't even know if I said that right or elegantly, that you have to really facilitate here. And after getting it in and actually finally getting to work, I was like, no bueno, I can't do this. This is a little too hard for me. So then I started looking at these other alternatives at the time, just approaches, and the other logical thing was, okay, we have REST is very well defined. We have lots of schema files out there all over the planet. So, okay, we just pull the tools, or we just import a OpenAPI schema, and then it'll automatically make our tools, and we'll have to do like a little bit of things, and then that's it. That's the solution. And the things I ran into. So yeah, it builds all the tools. Like I don't have to worry about that anymore, but I still have a lot of glue code that I have to account for. And it's funny because a lot of times we'll make like one thing easier, and then it creates like other problems that then we have to deal with. So maybe like 2 problems solved, 5 new problems, or something along those lines. So you have the custom logic stuff that you still have to do. Like how, we have these tools now. How do you filter them? How do you categorize them? Dynamic, selection of said tools, yada, yada, yada. So what that turns into is, and I just said one spec file, 100 tools, but some of these spec files have lots of endpoints, lots. So then you are dealing with I think the core thing here that you run into is what they call you're bloating the context window. So you're providing so many tools that the AI robot is getting confused because things are not relevant to what you're trying to get out of it. It's getting a lot of different stuff, and just I've read a lot about this. I don't know what the guidance is now. It's been a few, and this stuff changes so much. But I think generally what I've read is like you don't want to provide more than like 10. Or not 10, like 20 to 30 tools, I think, maybe. Like once you start throwing in like more than that, you're hitting like massive confusion. Your results are not going to be the greatest. Performance, degradation, all these things. You're just not going to have a good experience. It's going to be a little bit rough. So this is like when it's like, okay, let's try to build an MCP server and see what happens. And there's many projects out there that make some of these things very easy. FastMCP, FastAPI, there's a lot of stuff to where you're not starting from the ground floor. You got some help, and you have a lot of good documentation. So one of the quotes that I think is really spot on. So Abraham Lincoln said that MCP is probably the only tech that has more builders than users. And he was very ahead of his time with the statement. I agree, and it's still relevant, believe it or not. So when I was going through and actually doing these slides, someone said that you got to do like a side-by-side with a few of the attributes of each, because that'll be easier. Because if you do one section on one thing and one section on the other, it'll be confusing. So I did want to line this up. So RESTful APIs, they're built for me. They're built for all of you. They're built for humans to write some software. Like, let's go. MCP wasn't built for me. It was built for models. And this, to try to basically, expose tool, connect tools, data, stuff safely. Well, safely is relative sometimes, but yeah. So REST, as we discussed, it is an architecture. It's not a protocol, but it does use HTTP. MCP is an open standard. Standards are good, right? Public specification, et cetera. So, and this is the big one here for me, because I think so I remember the last time I attended and presented at like an Ansible Fest, like way back, and like Terraform was up and coming and stuff, and in the beginning I had this thing of like, oh, is Terraform better than Ansible? Is Ansible better than Terraform? And just like the last talk, as I grew and I started using these tools, I'm like, okay, what kind of, that's the wrong question. One is not better than the other. The question is, okay, you have tools, I have a use case. Which tool do I use for this use case? It's as simple as that. And one of the things that makes those tools fundamentally different, and one thing that causes actually a ton of confusion, is one is very stateful with very big state files, and the other is not. So stateful, stateless, I think that's probably one of the fundamental differences about what makes those tools different, declarative, imperative, et cetera. So just like with REST and MCP, one is stateful, one is stateless. Well, that's a big difference. That changes things. So that RESTful API little diagram that I put together with like the pretty boxes, and it was very beautiful, very elegant. If I take that beautiful diagram and I try to like retweak it for MCP, it probably looks something like this. So you have host all the way on the left. So, see, this is kind of like, it's funny because like when I think of host, I think of like my MacBook, or I think of like a server connecting to a network. And this is kind of confusing because like in this world, like a host is actually an LLM application. It's the execution layer for this. So like Claude Desktop or like an IDE or something, that's considered a host. It's like virtual private context and virtual private cloud. Let's just kind of say the same thing, and they mean completely different things. So basically what's going to happen here is it's going to use JSON RPC for the transport, and those fixed verbs, with REST that we talked about, we flip that over, and kind of what we have here is resources, prompts, and tools. Now all of us are probably prompting experts at this point. You're just templating what you want and feeding your stuff. Like prompts are not that hard to wrap your head around, but resources are interesting because resources are basically a way to return structured data in a sense, and then load context. So AI agents can do things, and it's read only. So I mean, it's almost like I guess if you wanted to try to make a comparison, it's like a Git, request with REST, maybe a little bit, but not really. This is why it's hard to compare things, because there are similarities with certain things, but in a lot of ways they're fundamentally different. So you have that thing where you've pulled in the context, you have the resources, and the tools are where the action happens. That's your execution. And I guess if you wanted to compare the frameworks, like Git would fall under the resources, and the put, post, and delete would fall under the tools if you wanted to try to draw that conclusion. But again, different things. So the thing that's really interesting here is it's not, request response. Like you're opening up something that is, continuing to stay up, and that server can actually initiate stuff back to the host or the client. So I sped through this part right here in my slides, but I have that content, context, and logs down there as an example of something that's getting, shot back to the client. And somebody said this to me, and I didn't actually. You'd have to fact check this, or not fact check, but this is the way I thought this was a cool thing. So content is kind of like the what. So you can almost think about it as like the actual response, kind of how you get a response with REST, like you're returning something. And then the context is the where, like the stuff that's getting loaded in the context window. And then the logs are the how, like you have all this stuff coming back. If there's a problem, you have just continual stuff streaming back to the client. So it's this thing that it's like a loop. Now, going from when I went from, just trying to do all of this in REST is really hard, and I can't do it very well. So this is when I was like, okay, I'm gonna build this MCP thing. And it's funny, because these examples work now, but when I ran them a few days ago just to make sure they still worked, because I built them a long time ago, and of course everything was broke. So much has changed since when I first built them, So I had to go back. They do work now, though, but you better try them quick, or they might break again. So looking at what makes the MCP experience actually a little bit different is decorators automatically generate the schemas from your doc strings. So that eliminates, the way that this is fundamentally built is it eliminates a lot of stuff that I was having to do. So really reduces and almost eliminates a lot of the glue code I was putting together, which wasn't the best. But you're not accountable or on the hook for the JSON RPC, like all the message handling stuff, and no more agent loop. So when I didn't have to do the agent loop part of this to get it to actually work, I was sold. I was like, yep, let's go. Much cleaner, much more elegant, much less lines of things, and much more consistency. So it's interesting when you start using, or you're building, or you're something programmatically. A lot of times, what I would do is I'd go into Postman, and I'm building these calls and trying to figure things out, and then I end up moving to request Python or something, and I build my thing. I try to help. I'm not an expert at many. In fact, Malcolm Gladwell. Yeah, I think Malcolm Gladwell. He didn't do the research, but the whole 10,000 hours thing. 10,000 hours of not just saying I work in IT or I work in network engineering, but intentional practice. That's what makes you an expert. Now, there's real research behind that somewhere, but I don't know what it is. But so guess who doesn't have 10,000 hours building this stuff? This guy. That's a lot of time and a lot of intentional practice for something that hasn't been around that long. And I don't know very many, personally, very many people that do. That's a lot of time. So one of the things, that I get a lot of questions on LinkedIn for help with certain things, and it's funny because one of the questions that I've gotten the most that I've actually been able to help people with is, and these are some of them are software engineers, is how do I connect to the thing? Can I do it from Postman, or what the heck is going on? This documentation's out of control. Was it generated by an LLM? Whatever. So the experience of even starting to get connected here is a little interesting. So generally what happens, we want to get started, we want to start testing, we clone some repo that has some things in it. I just use the repo that I have these tests from. So we clone that down, and then we are all good humans, and we create virtual environments with a good version of Python that's compatible with all the things we want to do, because we're responsible. I always use 3.11 for the past 2 months because it just seems to work with everything. So I create a virtual environment, and then I resolve all this dependencies, install my dependencies. And this is actually where some of the folks that I was helping out, they are stuck. What, isn't it ready? How do I connect to it? It's there. Do I just launch a Python file? Why is this so confusing? And generally the way that this will go is if you're using something like well, actually, if you're using like the Claude codes or the Geminis, I started experimenting heavily with like Claude code like a few months ago, and it has like this, a slash and MCP, and then you can just put in some things and it'll do it for you. But a lot of what we were doing before, and kind of what you still do in some circumstances, you have this, you have a JSON file. And it defines all of your MCP servers that you want to be available to something like Claude code. And these look for these files in a certain place, et cetera. So make sure that whatever host that you're using, that you put the file in the right place, because that's a common problem. And then you have basically two things. If you're running it locally right here, you have the command, which is basically it's just a path to an interpreter. It's your execution. And then you have a bunch of arguments you can pass in. And if you look at, I should have like pulled out one of my other ones. It's like these arguments can just get out of control because you can pass in so many things. But yeah, the argument here is just passing to the actual server that we want to run. So basically in this scenario, I'm not in my Linux terminal, I'm not going to this directory and saying, Python, run this file. Okay, I have a server running on my machine. No, this is going to do that. It's going to call the interpreter and pass in my args when I open up whatever the host is. So in my case, I did this with Claude Desktop. So I open, and I had these little things here that I didn't even, look at that. I had animations and everything, and I put the cart before the horse, and I just talked through it. Anyway, so after I do this, I have this file, and it's saved. Like, what do I do now? Well, now all you got to do is open up your host. So, and then you can toggle the tools. A lot of times, there's just so many tools, and this is a good way. So if I have like a list of 20 or 30 tools, I can say, okay, for this thing, I'm just going to have these 4 selected. And that way, every time you open up the host, most of them will remember that, and those are the tools that you will start with. So everything gets instantiated as soon as you open up the application. So now I can go in and I can just have a fancy way to say, what are Connor McDavid's stats? And even like I added, this was really cool because I started adding a few other things. I just copied that and I'm like, why don't I compare his stats to like Austin Matthews? They lost Marner, and it's just like they're just gonna stink this year because Marner, nobody appreciated him, and he was a very good supporting player. Sorry, it drives me nuts, but yeah, I get all the stuff, and I can just do a lot more easier. So now, thinking about this and just thinking about like how do we scale, and I think it was actually Jeremy Schulman at some other event, but he was saying something about how like he had this little spiel about like getting vendors to get on board and accountable to start doing things. I can't say it the way he said it. He said it much better and elegantly, but yeah, push the vendors that you're using to start doing this. And that always made me think of there was a quote from Batman Dark Knight Rises from Commissioner Gordon where he said, MCP is the standardized interface we deserve, but not the one vendors need right now. So they'll question it because it can take it, because it's not just another API wrapper, it's a context provider, a capability exposer, a model context protocol. So thank you, Commissioner. So plowing right ahead, and this is, I don't know, this is even hard for me to say out loud, but because I think like some of these words, it's hard because like just marketing and industry, like we've abused like so many words and tried to make them like say so many different things that eventually they like lose meaning. So I'm going to try here to be genuous and say this. So one thing I sort of kind of figured out is like instead of thinking about like for me it's always been about the endpoints, the endpoint this, endpoint that. You have to like shift that thinking from endpoint to actual intentions. So like on the left here, in the left corner, we have this endpoint mapping, say like an API wrapper, and we've all built stuff like this where, hey, we get a list of like a bunch of devices, and we have this ID that we return, and then we insert that into another call, and that returns a thing, and then we insert that into another call, or we take some data out of that and do another thing. So we're really like looking at this endpoint-based way of architecting things. And with this stuff, it's a little bit different. So it's more intent-based, semantic abstraction. So if you think of the whole thing, like, okay, I want to, I want to back up a config. I can hardly see my examples down there. I want to run a compliance check. I want to back up a device configuration. It's like this one thing that is composed of like, many different tools that meet that outcome. So in my mind, like when I try to like think of it and like reason through it, it's like, okay, like if I'm wrapping APIs, which I hope we've already established that this is a real thing. You can use MCP to wrap APIs. Like that is a real thing. You're doing direct endpoint to tool mapping, and so you become a systems integrator. That is what your AI is doing. And you're spending lots of money on tokens for maybe nothing. And oh wow, I can't even see the white, whatever that says, but I think it was, a full sort of domain operator or an expert in a specific domain. Like that is what the AI, like kind of like where you want to go with this newish thing with MCP. So as we start to like layer on, we have this architecture and we start to try to layer on intelligence, we don't want to live in, hackers are never going to stop. They're just not. So I would love to live in this world where we could just run everything everywhere. Everybody's happy. We don't have to worry about security. Wouldn't that be nice? But unfortunately, we're never going to live in that world. So as far as like a shifting in thinking, capability filtering becomes very important, context-aware, tool exposure. So when you think of like roles and personas are really different. Like let's just say the persona of ops and a persona of like engineer. So you have these different roles. You already have RBAC. You already have organizational security. How do we get these things that we've built to be able to be connected and sort of like architected with those things? So we have to be able to define roles. And one of the great ways that you can do this is actually defining tags. So having tool exposure based on tags. So say that I have an ops team and I just have a health tag. That might expose, tools like this, like get the system health or something, maybe restart certain types of services, et cetera. And then again to the engineering side, backup configuration or whatever a network engineer or a systems engineer would be able to do. So this is kind of as we start to see these mature, like this is where it's going to go. We have an architecture, we've built an optimized MCP server. We're trying to build it the right way, and then we can start doing neat things like this. So what about scale, though? And this is something that's really important, is like we can science experiment all day, but like what are the paths that this is going to go to where like you can, an enterprise can use this thing, or they're going to buy something and it's scalable. So I think this is what I have my money. Well, I shouldn't say that here, but my money would be on like history. So if you look at like the proliferation of APIs around the planet, and then suddenly these API gateways pop up, okay? Makes sense. So now we have this proliferation of MCP servers all over the planet. So wouldn't it make sense that MCP gateways are going to start to pop up? Maybe. One thing that's already happening is there's a lot that are, well, not a lot, there's some that are vendor hosted now. So a vendor might have a platform that's like cloud-based and they just expose an endpoint, and that's how you connect to MCP. Am I over time? Holy smokes. Okay. So that's like I guess the vendor hosted methodology. That's already happening. And then you have the private stuff in your own data centers, and that's probably going to be Kubernetes clustered, like just kind of the same old way that we're architecting those things now in data centers. Again, adding intelligence doesn't mean scale. These are two very different things, different problems to solve. There's some bullet points there as to why that makes sense. And I'm going to come to a conclusion now. So thank you. There's my pretty QR code. Thanks a lot.